All right, guys. Thanks for joining us today. And today we'll be looking at a very important topic or a very important concept. Day before yesterday, that was on Wednesday, we looked at understanding indices. Okay, so today we want to look at understanding logarithm. So, all right. Now, when you see any function in this form, in the form of y equals to log x base a. This is an example of logarithm. So it's called logarithmic function. So, and this is how it is. If you have log x, and so this is called log x. So this is log x, and it's having a base of a. So this is the base. Don't forget in indices too, we also have base and power. For example, you can have this is in indices, this is the base, and this is the power. Okay. So it can be in this form. You can have y equals to log x raised to the power of a in base b. This is also a logarithm form. This is a logarithmic function. You can have it in this form also. You have 2x plus 3, then base c. It can also be log, let's see, 1 over 2 base a, for example. So when you see anything in this form, this is our called logarithmic function, okay? So that is what we'll be looking at today. All right, so the next thing we are going to look at is we'll look at laws of logarithm. That's what I want to look at now. Laws of logarithm. All right. The way indices have laws, then also logarithm also have laws too. So we'll look at the laws of logarithms. All right, the first law we'll be looking at is, so this is how the first law goes. If you have log a is a, then your answer is 1. Also, if you have log 1 base a is equals to 0, that is log 1 in any base is 0, okay? Log 1 in any base is equals to 0, and log a base a is 0 is 1. What it means is that if, for example, I say find log 50 base 50, okay, so far the base is the same as the log, your answer is 1. You don't need to argue it. So far the base is the same as the log, your answer is 1. It can be log x base x, your answer is 1. It can be log y base y, your answer is 1. But if it is log 1 in any base, it can be base a, it can be base b, it can be c, it can be any base at all. Your answer is 0. So that is what the loss is talking about. Also, then if you have, let's see, then the second law, when you have, if you have log, okay, All right, let's look at the second law. So when you have, let's say you have log m n in base a, which is equals to, so log mn base a in logarithm is the same as log m base a plus log n base a. So vice versa. If you have something like this is what you have as your answer. Then the third law, we have m divided by n in base a is the same as log m base a minus log n base a. Then number 4, if you have log m raised to the power of k base a. So according to logarithm, this k we move to the back of this log, so as k log m base a. So, and also vice versa, if you have it like this, it will come here, it will move to the top. So vice versa. Then the fifth law, if you have log m a, which is equals to log n base a, then m is equals to n. So which means this one becomes this one because they are of the same logarithm. Then finally, the sixth one, which is the law of changing base. For example, if you have log m base a now, or let's say log m base n, and you want to change the base. So by changing the base, we are going to have log m. Let's say we are changing the base to a. So it's going to be log m base a divided by log n base a. So it's as easy as that. So that is basically the laws of logarithm. So let's take examples. Let's start solving some examples. Okay. All right. So let's say that we have to solve this. So let's say that we have to solve this. That is log 27 is 9, then minus log 81 base 3, then minus 3 log 3 base 27. Now, if you have to solve this, this is simply the same as, first of all, if you recall when we did indices, I told you I said anytime you're solving indices problem, what you do is that you try to express all the numbers you have, try to express it in index form. So you can see that here we have different bases. We have this is base 9, this is base 3, base 27, but there's something common about them. All of these numbers can be expressed in the index form of 3. They all have the same base of 3. So, and also 27, 81, and 3. So they all have something in common. So what it is, I say log 27, then this 9 will be the same as 3 raised to the power of 3, or 3 raised to the power of 2 rather, not 3. Then minus log 81, and this is 3. Then minus 3 log 3, that's 27 is 3 raised to the power of 3. Okay. So according to the law of indices, law of logarithm, this when a base is having a power, it automatically comes here as 1 over. So it's going to be 1 over 2 log 27 base 3. Then minus, this is going to be log 81 base 3. Then minus, this will be 3 times 1 over 3. So this 3 is the one coming as 1 over here. Then log 3 is 3. Okay, then what are you going to have? You're going to have log. Remember that law of logarithm, that this one as the base will come as a power. So it's going to be 27 raised to the power of 1 over 2 is 3, then minus this is going to be 81 is 3 raised to the power of 4 is 3, then minus 3 times 3 times 1 is 3, 10 divided by 3, that's 1. And log 3 is 3 is also 1 too. Then we are going to have log 3 raised to the power of 3 raised to the power of 3 times 1 over 2. Then log 3 raised to the power of 4 is 3. Then minus 1. 4 minus 3 is 3. Okay. Then the next thing we have is that log 3 is 3, which is power of 3 over 2. Then minus log 3, which is the power of 4 is 3. Then minus log 3 is 3. Okay. So we can do something. You notice this 2 over 3 can move to the back here. This 4 will move to the back here. So we discover that we are going to have 3 over 2 log 3 base 3 minus 4 log 3 base 3, then minus log 3 base 3. This is 1, this is 1, this is 1. So we are going to have 3 over 2 multiplied by 1 minus 4 multiplied by 1 minus 1, which is 3 over 2 minus 4 over 1 minus 1 over 1. We find the LCM, which is 2. Then this is going to give you 3 minus 8 minus 8 minus 2, which is going to be minus 7 over 2. That is your answer. How that's clear enough? Let's take another example. Let's say that you have log x is 3, then plus log 3 is x, which is equal to 10 over 3. Okay, now you notice here we have log x is 3 and log 3 base x. So you can actually change the order. So how do you do that? You just do the inverse. So it's going to be log x is 3 plus 1 over log 3 base x. Log x is 3, which is equal to 10 over 3. So very easy. Just find the LCM, which is going to be 3 log x is 3. So this is going to be 3 log x base 3 squared plus this is going to be 3, which is going to be 10 log x raised to the power of 3. So this cancel out. Then you can say let log x base 3 be equals to y. Then you can have 3y squared plus 3, which is equals to 10y. You create this as automatically leads us to quadratic equation, then you have minus 10y plus 3, which is equal to 0. Okay, let's try to solve this quadratic equation. Okay, in order for us to solve this quadratic equation, so we can use factorization method. We use this 3 to multiply this 3 here, that's plus 9. We look for two numbers that when we multiply them, it gives us 9, and when we sum it together, it gives us minus 10. And that number is 9 minus 9 minus 1 will give us. So we have 3y squared minus 9y minus y plus 3 equals to 0. Then we can put it in bracket like this. So it's going to be 3y into y minus 3, and then minus 1 into y minus 3, which is equal to 0. Therefore, we'll have that 3y minus 1 into y minus 3 is equal to 0. Then we now say that 3y minus 1 is equal to 0 and y minus 3 is equal to 0. Then y will be equal to 1 over 3, or y will be equal to 3. Then we can come back to that, our equation. You know, we said x over 3 is equal to y, right? So the first thing is that our y is 1 over 3. So which is going to be log x is 3, then 1 over 3. So x is going to be 3 raised to the power of 3 raised to the power of minus 1, or 1 over 3. Or we can actually see that log x plus 3 is equals to 3. Then this will push this up. Then we have x is equals to 3 raised to the power of 3, which is 27. So So that's it. Let's take another example too. Let's say that we have log, let's say that we have log x is 27, which is equals to 3 or 2 over 3. Okay, for us to solve this type of question, now what we are going to do is that we are going to say that log x is 3, or very easy. Okay, so let's write it well. So it's going to be x with 20, so log x with 27, which is equal to 2 over 3. So this, we push this up, then you are going to have that log, no, sorry, no, it's not a log again. You have, that is x is equals to 27 raised to the power of 2 over 3. Then you can express this in index form. So 27 is the same as 3 raised to the power of 3. Don't forget that there is 2 over 3 here. So 2 divided by 3. So this 3 cancels 3. Therefore, x is equals to, this is equals to 3 raised to the power of 2. And that is 9. So that's your answer. All right, let's take another example. Now let's say that you have log x plus 2 log 5 equals to 2. Now notice that this is not having a base, so it's a natural base. So let's just say it's in base 10. So it's an assumption, let's say it's in base 10. So you can have log x plus this, we have to come to the top here. So it's going to be log 5 raised to the power of 2, which is equals to 2. And this is going to be log x plus 10 raised to the power of 5 raised to the power of 2 is 25, which is equals to 2. And don't forget that when you have two logs that is joined together by addition sign, so you know that you can combine it to the product. So it's going to be log x times 25, then d, which is equals to 2. Okay, so don't forget here I told you that because it's natural, because if you don't see any log that does not have anything in the base, is 10. So you have 10 here, and it's going to be 25 x, which is equals to 10 raised to the power of 2. Then 25 x is equals to 100. Then x will now be 100 raised to the power divided by 25, which is what? 4. So that is the answer. Okay, so all right, let's move ahead. Now let's see that we also have, let's say that we have log 2x plus 1 minus log 3x plus 2, which is equals to 1. So this is what we have. All right, this is subtraction sign, right? So what that means is going to be division. So we are going to have log 2x plus 1 divided by 3x plus 2, which is equals to 1. All right, so let's write it well. So it's going to be log x 2x plus 1 divided by 3x plus 2, which is equals to 1. Don't forget I told you that since there's no base here, so it's going to be 10. So this 10 will usually push this up. Then we're going to have 2x plus 1 over 3x plus 2, which is equals to 10. Now, anytime you have two fractions that are separated by equal to sign, so what you do is that you cross multiply. So if you cross multiply, you have that 2x plus 1 multiplied by 1, which is equals to 10 into 3x plus 2. Then you have 2x plus 1 is equals to 10 times 3x is going to be 30 x plus 20. Then you collect the lactants. So if you collect lactants, you're going to have 30x minus 2x, and which is equals to 1 minus 20. So this is going to be 18x, which is equals to minus 19. Therefore, x is equals to minus 19 divided by 18. Okay, so that's the answer. Let's move forward. All right, so let's say that you also have another example like this. Let's say you have log, okay, log, that's 4x plus 1, then in base 3. And so now this one, we are given the base, okay, so this is going to be 3x minus 5, then base 3, which is equals to 2, okay. Now this is also division, this is also minus, so that means when you are combining the two logs together, it's going to be division sign. So which is going to be log, that is 4x plus 1 divided by 3x minus 5. Then you want in base 3, which is equals to 2. So let's write it well. So it's going to be log, that is 4x plus 1, then divided by 3x minus 5, which is equals to 2, then in base 3. So this base will push this 2 up. So it will now be 4x plus 1 divided by 3x minus 5, which is equals to 3 raised to the power of 2. And 3 raised to the power of 2 is 9. Okay, then we're going to have 4x plus 1 divided by 3x minus 5, which is equals to 9. Because multiply just like the other example, we are going to have 1 multiplied by 4x plus 1 plus 1, then which is equals to 9 into 2x minus 5. Then we are going to have 4x plus 1, which is equals to 18x minus 9 times 5 is 45. Okay, then we are going to have 4x plus 1, which is equals to 18x minus 45. So collect the like terms. Collecting the like terms, we're going to have 8x minus 4x, then which is equals to 1 plus 45. Then this is going to be 6. Now this is going to be 4 rather. This is going to be 4 rather. Points, then which is still going to be 46. And you divide both sides by 4. Then what are you going to have? You're going to have 11, then 11 number, that's 2 over 4. That's your answer. Okay, that's interesting. Let's take another example. Okay, this one is going to lead us to quadratic equation. All right. So this is going to lead us to quadratic equation. Now, when you have a log of x squared plus 9, then in this 10 minus 2 log x this 10, which is equals to 1. All right. Now this is, so first thing first is that this 2, you have to shift it to this point as a power. So you're going to have log x squared plus 9 this 10 minus log x squared this 10, which is equals to 1. All right, so now let's use that law. So the law, that subtraction law, so which is going to be log x squared plus 9 divided by x squared base 10. You see base 10, which is equals to 1. And this will then push this up. Then we have x squared plus 9 divided by x squared is equals to 10 raised to the power of 1, that's 10. Then at this point, you can cross multiply. Then you simply have x squared plus 9 is equals to 10x squared. Now you notice that you're going to have, when you rearrange, let's collect the like terms, you're going to have 10x squared minus x squared is equals to 9. Then you're going to have 9x squared is equals to 9. Then, all right, this remove this, so x squared is equals to 1. Then x will be equals to plus or minus 1. Yeah. So if you take the square root of 1, so you have plus or minus 1. That is our answer. So our answer can either be plus or minus 1. Okay. Let's take another example. Now let's see that we have log plus x squared plus 24 in base 10, and then minus log x base 10, which is equals to log 10 in base 10. All right. So first we do that, we try to combine this one, this log and this log, we combine it. So if you are doing that, that's going to give us division. So we have, that's going to be log x squared plus 24 divided by x base 10, which is equals to log 10 base 10. So this automatically cancels this. You remember that log we did, whereby we have log m base a is equal to log n base a, then m is equals to n. Then we'll have, okay, then we'll now have that x squared plus 24 divided by x is equals to 10. Cross multiply. Then we'll have that x squared plus 24 is equals to 10x. Okay, so you can see that we're already heading to quadratic equation. Then we have x squared minus 10x. We rearrange, this is plus 10, it will come as minus 10, then plus 24, which is equal to 0. Okay, once we have that, we'll factorize. You can factorize, you can use your calculator. So now, but let's just factorize. So this is 24, two numbers that you can multiply the ability for, that's 12 and 2. So and it's going to be, no, let's use 4 and 6. 4 and 6, so that's minus, minus. So minus 4 minus 6, we actually do, yes. Minus 4 minus 6, we can't use 12 and 2 because by the time we sum it together, we will not get, well, by the time we multiply it, we cannot get plus 24 with minus 10. But with this one, minus times minus will give us plus, 4 times 6 will give us 24, and minus 4 times minus will give us minus 10. So we use 4 and 6. So with that, we now see that x squared minus, instead of writing 10x, we're going to write 6x minus 4x, which is 6 minus 10 minus 10x, 10 plus 24 equal to 0. Then we put it in brackets. Then we are going to have x into x minus 6. Yeah, then what's common here? Minus 4 is common, and we'll be left with x minus 6 inside. Then it's going to be x minus 4 into x minus 6, 27. So at this point, either x minus 4 is equal to 0 or x minus 6 is equal to 0. Therefore, x is equal to 4 or x is equal to 6. So that is our answer. That's our x. Okay, finally, let's solve the final one. Let's say that we have log for today. So let's say that we have log x base 3 plus log 2x plus 3, then base 3, which is equals to 2, or so rather, which is equals to 3. Okay, you can see the same base, right? And they have addition in between, so we multiply. So it's going to be log x times 2x plus 3 plus 3, then base 3, which is equals to 3. So this, we push it up. You're going to have x into 2x plus 3, which is equals to 3 raised to the power of 3. This is going to be 2x squared plus 3x equals to 27. If you collect the like terms, yeah, plus 3x minus 27 equals to 0. All right. So for this one, I'm not going to solve this one. So I'm not going to solve the quadratic equation. So I want you to solve it and you drop your answer in the comment section. Okay, that will be all for today. Thank you so much for joining. Make sure that you like the video, you share, you comment. It's very helpful. A brother and sister will be in need of the video. Okay, and don't forget to subscribe. Thank you so much. Have a wonderful day.